This Introduction to Python series is part of the EPSCoR Track 2 DDMD workshop. This presentation focuses on Python functions. A function is an algorithm in a chunk of code that can be called by name. A function can be called from anywhere in a program's code, including code within other functions. A function can receive data via its arguments. A function may have one or more return statements. And functions provide the ability to add abstraction to our code. By this, we mean that it helps to eliminate redundant or repetitious code. Throughout this workshop, we've leveraged several built-in Python functions. For example, as we worked with lists, we used the length function to find the length of a list. We used the built-in sum function to find the sum of the elements within a list. We used the max function to find the maximum element in the list. These are built-in functions that are provided by Python. And we remember that, for example, finding the length of list, len parenthesis list. List is the argument, which is a list of integers. Length is the name of our function, and we know that the length function has a return value, which is an integer that represents the number of elements in the list. It's important when you call a function within your Python program to understand the requirements of that function. For example, we know that the built-in function len returns the length of an object. So if we try to call that function with an argument of the integer 10, this generates a Python error, and the error is that the object of type int has no length. So you cannot call the built-in function length using an integer as a parameter. Let's say somewhere in your Python program you needed to find the sum of the integers between 1 and 10 inclusively. So you would maybe assign lower to the value 1, upper to the value 10. You'd initialize your range sum to 0. Then you'd write a for loop where you would loop through the integers between lower and upper, and you would add that integer to your range sum. Now, later on in your program, you needed to find the sum of the integers between 100 and 200. So now you assign lower the value 100, you assign upper the value 200, and you repeat the identical code from the previous functionality where you initialize range sum to 0, and then you loop through the integers from lower to upper plus 1, and you add that integer to your range sum. A Python function is a block of code which only runs when it's called. You can pass data, known as parameters, into the function. A function can return data as a result. A Python function is defined using the def keyword. So here's a very simple example of a function. The name of my function is my_function. So the first part of a function is the function header. The function header starts with the def reserve word, then the name of your function, then open and close parentheses, and a colon. This is our function header. All of the code that's included in my function is indented within this header. So in my example, the function prints hello from my function. This code is not executed until we call it. So to call the function, I specify the function name. So in my code, I say my_function, open and close parentheses, Now the function is called, it's executed, and hello from my function is outputted on the screen. Information can be passed in two functions as arguments. Arguments are specified after the function name inside the parentheses. You can add as many arguments as you want. You just separate them by a comma. So I've modified this simple function example, my function, where I've added a parameter. So in my function definition, in the header, I have the reserved word DEF, my function name, and now within the parentheses, I added a parameter called name. Again, this function is not executed until it's called. Then somewhere in my Python program, I can call this function. So the first time I call it, my function parentheses, and I add the argument Carol. Carol is the argument, and it's passed into the parameter name. So it's like saying name is assigned Carol. So when the function is called, it'll print hello from my function, Carol. The next time I call my function, I pass in the argument John. John is assigned to the parameter name. Again, just like saying name is assigned John. And we print hello from my function John. I call the function again, this time with an argument Barbara. Barbara is passed in to the parameter name. Name is assigned Barbara, and hello from my function Barbara is printed. By default, a function must be called with the correct number of arguments, meaning that if your function expects 2 arguments, you have to call the function with 2 arguments. Not more and not less. There are ways to define optional arguments, but we're not going to address that here. We modify our simple function to include 2 parameters. So now my function has the parameter first name and last name. We call it the first time with the arguments Carol and Lushbow. Carol is assigned to the variable first name, Lushbow is assigned to the variable last name, and we print hello from my function Carol Lushbow. We call it again with the arguments John and Jones, and hello from my function John Jones is displayed. Lastly, we call the function again, but this time we only pass it 1 argument. So Barbara is passed into the argument first name, but we don't include an argument to be assigned to last name. The Python interpreter generates an error message, and the error message we get is that my function is missing 1 required positional argument last name. This is a very clear error message saying that we called the function without including an argument to be passed into last name. When we define a function, we're frequently going to want it to return a value. To let a function return a value, we use the return statement. If we revisit our built-in functions, we know that each of those functions return a value. For example, len returns an integer that represents the length of the argument. Sum returns a value that represents the sum of the elements within an argument. Max returns the maximum element within the list. Each of those built-in functions return values. Let's consider an example where we've modified my function to return a value. So in our function header, we have def space my function, and it has parameter x. Now our function is going to return a value. So it's going to evaluate the expression 5 times x and it's going to return that value to the calling program. That's our function. Again, it's not going to execute until we call it. So the first time we call it, call it with the argument 5. So 5 is assigned to the parameter x. Our function then will return 5 times 5. That return value is assigned to the variable value 1. We call our function again. This time we pass in the argument 10. 10 is assigned to the parameter x. We evaluate the expression 5 times 10. We return that value to the calling program. That value is assigned to the variable value 2. Lastly, we pass in the parameter 15. 15 is assigned to x, and we return the value 5 times 15. Lastly, we print value 1, value 2, and value 3. Let's revisit our example of wanting to find the sum of integers between a lower and upper bound and show how defining a function will help us to eliminate code duplication. Here is an example of a function that will find the sum of a range of integers between a lower and an upper bound. So in our definition header, we've named our function SumRange, and we have 2 parameters, lower, which represents the starting integer, and upper, that represents the upper integer. And the function is supposed to return the sum of the integers between lower and upper inclusively. So the code that we're going to implement within this function is the code that we had previously duplicated. So we're going to initialize the range sum to 0, and then we're going to use a for loop to iterate through the range from lower to upper plus 1, and we're going to add those integers to the sum. Once this code has been executed, we're going to return the range sum, where range sum represents the sum of the integers between lower and upper. Now somewhere in our Python code, we're going to call this function twice. The first time we call our function SumRange, and we pass in the arguments 1, 10. So 1 is assigned to the parameter lower, 10 is assigned to the parameter upper. That function returns the sum of the integers between 1 and 10, and we assign that sum to the variable sum1. We call our function again. This time our arguments are 100 and 200. 100 is passed into the parameter lower, and 200 is passed into the parameter upper. Our function finds the sum of the integers between 100 and 200, returns that sum, and we assign that sum to the variable sum2. When we print out sum1 and sum2, we see that the sum of the integers between 1 and 10 is 55. The sum of the integers between 100 and 200 is 15,150. When you develop a function, the first statement under the function heading should be a docstring. And this docstring provides information regarding the functionality of your function. So notice in our example, SumRange, under the function heading, we have a docstring. And recall that a docstring begins and ends with 3 double quotes. Within these quotes, we first start with our arguments. So we give information about the function arguments. And in this example, arguments, integers representing the lower bound and the upper bound. Then we have information about the return statement. So this function returns the sum of the integers between the lower and the upper. These docstrings are especially helpful when you or somebody using your function wants to retrieve information regarding that function. So in this example, I show how you can use help to get information about a function. So the first statement, help, and within parentheses I put len. I'm asking the Python interpreter to give me some information about the built-in len function. The second statement, help, then within parentheses sum range, I'm asking the Python interpreter to give me some help information regarding the function sum range. And that, of course, is the one we wrote. So if you look at the output, the first few lines gives us the information about the len function. So it says that it's help on the built-in function len, and it's part of the built-in module. And it tells us that the length has a parameter of an object, and it returns the number of items in the container. Next, we get help information on our function sum range. And in sum range, notice that it prints the function header sum range with the parameters lower and upper, and then it says the arguments are integers representing the lower bound and the upper bound, and that it returns the sum of the integers between lower and upper. So the information that we provided in the doc string is what is presented to the user when they want to get help on a function. It's also important to note that these doc strings, which are part of the functions, provide internal documentation for our program. So if we give our program to somebody else to modify, they can read these comment statements or doc strings to get a better understanding of our function. Let's develop a function that determines whether or not an integer is a perfect number. A perfect number is a positive integer that is equal to the sum of its proper divisors. A proper divisor of a positive integer is any divisor of that integer other than the number itself. So the smallest perfect number is 6, which is the sum of 1, 2, and 3. Other perfect numbers include 28, 496, 8,128. Our function will receive an integer as a parameter. It's this integer that we're going to check to see whether or not it's perfect. We're going to calculate the sum of this integer's proper divisors. Then we're going to check to see if that sum equals the number that was passed in. If the sum of its divisors equals that number, we're going to return true. Otherwise, we're going to return false. Here's an example of how we might implement the perfect number function. So our function header, we're calling our function isPerfect. And I like that name because it specifies that we're basically asking a question. Is X perfect? True or false? So our function name is isPerfect, and we're passing in X that represents a positive integer. Next, we're going to start calculating the sum of its proper divisors. So we're going to initialize our divisor sum to 0. Then we're going to check every number between 1 and up to, but not including that number. And for each integer between 1 and the number, we're going to check to see if that number is a divisor. To do that, we take X and we divide it by I. And if the remainder is 0, we know it's a divisor. So for each integer, we say if X mod I is equal to 0, we're going to add I to our sum. We're going to continue that until we get up to but not including X. Once the for loop is terminated, we can check to see if our sum is equal to our number. And if it is, we're going to return true. Otherwise, we'll return false. Here's an example of a Python program that calls our isPerfect function 3 times. The first statement in this function, print isPerfect with an argument of 6. Our isPerfect function is called, 6 is passed into x. It calculates the sum of the proper divisors of 6, which is 1, 2, 3. It sums them up. It checks that yes, 6 is equal to 6, so it returns true, and true is printed on the screen. Our second statement is a print statement where x isPerfect is called and 8 is our argument that's passed into x. So x is now equal to 8, and we find the sum of the proper divisors of 8, and that sum does not equal 8, so the function returns false. The third print statement isPerfect. Instead of passing in a positive integer, we're passing in a string. And so this string is 6. X is assigned the string 6, and the Python interpreter generates an error message. And it says that a string object cannot be interpreted as an integer. Therefore, we're going to want to make a change to our isPerfect function to guard against this problem. I've made a modification to our isPerfect function by wrapping our code in a try except block. And as a developer, I need to decide what actions do I want to take in my function if an error occurs. And in my case, I've decided that I'm going to return false. So in our code, we have the code under try. Then if an error occurs while we're determining whether or not it's a perfect number, the code under the except will be executed and it'll return false. In a well-organized system, each part does its own job in collaborating to achieve a common goal. In a computer program, functions can enforce a division of labor. Each function should perform a single coherent task. For example, sum a range of integers. Each of the tasks required by the system can be assigned to a function. One of the strategies we use for problem solving is the top-down approach. Top-down design starts with a global view of the entire problem and breaks the problem into smaller, more manageable subproblems. This process is known as problem decomposition, and each subproblem is isolated. Its solution is assigned to a function. As functions are developed to solve subproblems, the solution to an overall problem is gradually filled out. This process is also called stepwise refinement. Now that we have our isPerfect function, let's write a Python program that allows the user to determine if numbers are perfect. So we're going to allow the user to enter positive integers, and as soon as they enter a negative integer, that indicates that they're done. So we'll get an integer from the user, and as long as it's positive, we'll inform the user whether or not that integer is perfect, and then we'll allow them to enter another number. So in this code example, the first thing we do is we ask the user to enter a positive integer, enter -1 to quit. What they enter into the keyboard, we convert to an int and we assign it to the variable number. While number is greater than 0, we call our isPerfect function, passing in that number. And we know that isPerfect returns true or false. So if isPerfect number returns true, we're going to print that number and say that it is perfect. Otherwise, we're going to print the number and say it is not perfect. Then we're going to ask the user to enter another number. We're going to stay in that while loop until the user enters a negative number. A sample run of this program shows our code prompting the user to enter a positive integer, enter -1 to quit. We enter an 8. Then the code prints out 8 is not a perfect number. And we're prompted to enter another value. We enter 6. The system prints 6 is a perfect number. We're prompted to enter another number. We enter 496. The system prints 496 is a perfect number. Prompts us to enter another number. We enter -1. -1 is not a positive integer, and that terminates our while loop. Some important function guidelines. When you develop functions within your Python code, place all of your functions at the top of the program. Python allows you to intersperse functions throughout your program, but I find it really helpful and important to define all your functions up front at the top of your program. Always include the doc string describing the arguments and the return value. Name your functions with verb objects to help describe what the function does. For example, calculate average, is perfect, load terms. Let's develop a Python program that'll calculate the mean, median, and range of a list of grades read in from a text file. Just recall that the mean is the average, the median is the middle value. So first the list will need to be sorted. If the number of values in the list is even, the median is the average of the middle two values, and the range is defined as the difference between the largest and the smallest value. Let's begin by writing a function that loads the grades from an input file into a list. So our argument will be the name of the input file that represents a list of grades, and our output of this function will be a list that's comprised of integers representing grades. So our function to load our grades from a text file into a list is called loadGrades. The argument is a string represents the name of the grade file, and we're specifying that the file's content is expected to have 1 grade per line. And we're going to return a list of numbers representing grades. So we're going to try to open the file for reading. We're going to initialize our grade list to the empty list. We're going to read each line from the file, convert it to an integer, and append it to our list. And when we're done with that for loop, we're done processing every line in the file, we're going to return our grade list. Some errors that we need to worry about is if the file wasn't found, and if we're not able to open the file, we're going to specify that the name that they gave us could not be opened, and we're going to return an empty list. Another problem that could occur is we could have a grade within the list that isn't a valid grade. That would throw a value error. So we're going to catch the value error. We're going to inform the user that a value error has occurred, and we're going to return whatever grades were loaded before the error occurred. The very last line in this code example shows how we could call this function. So it's an example of how we call loadGrades, specifying the name of the input file that contains the grades. This function returns a list of integers representing grades, and we assign that list to the variable grades. We're going to create a function that finds the median value in a list of values. So our input into this function will be our list, and the output will be the median value. Here's our function for finding the median value. So we call our function find median. Note that we use a verb object to make it clear what the job description of this function is. The parameter into this function is a list, and we expect this list to be a list of numeric values, and we're going to return the median or the middle value. The first thing we do is sort our list. We find the length of the list. We determine whether or not the number of elements in the list is even. If it is, we average the middle two values. Otherwise, we return the middle value. We use a try except block because a couple of things could go wrong on the execution of our function. First of all, the user could call our function with an empty list, or the user could call our function with values in the list that are not numeric. We also need a function that will calculate the average of a list of numeric values. So our function's name is calculate average. The parameter is a list of numeric values. And our function is going to return the average of the numeric values in the list. So we find the sum of the list of values and we return the average, which is the sum divided by the number of elements in the list. We're going to guard against zero division error in case the list is empty, and we're going to guard against the value error in case there was an element in the list that's not numeric. And in both cases, we're going to return an average of 0. Now we've created the following functions. Load values from an input file, find the median from a list of values, find the average from a list of values. And note that these functions that we've created will work on any numeric values. So it's not necessarily just for calculating grades, but a list of numeric values. Now we can write our Python program to process our grades. Here's an example of code that will process a list of grades from an input file. So first we load our grades. So we call our function load grades and we pass in the name of the file that contains our grades, and it's grades1.txt in the input files subdirectory. And this function returns a list of numeric values that represent grades. Next, we call our find median function, passing in our list of grades. So our find median function expects a list of numeric values and will return the median value. We call our calculate average function, again, passing in our list of grades, and the function returns the average of those grades. Now all we have to do is print our results. So we say the highest grade, and we use the built-in max function to find the maximum grade, and the lowest grade using the built-in min function. The median grade is the grade that was returned from our find median function. We calculate the range by finding the difference between the max and the min, and we can print our average grade.